of the most part of diseases in terms of alterations, hyper or hypo, of signaling molecules, and we can recover definitively the balance. If diseases are expressions of alterated concentration, which is the physiological concentration, I mean when you are in healthy condition, do I have kilograms of testosterone to be so in love of women? No. To be in love with you, I need to have testosterone, but every substance, in a very precise range of concentration at the level of the extracellular matrix. And this concentration is in the order of picograms per milliliter, femtograms per milliliter. We are used in pharmacology to think in terms of gram, a gram of antibiotic, or milligrams, hormones, neuropeptides, cytokines, growth factors are in our body at the concentration of 10 to the minus 12. Look, 0.000, femtograms, 0.0000. In our laboratory, we reproduce under the form of medication this unique concentration. That is the unique concentration to have the physiological effect and not side effect. Otherwise you have really severe side effect. This is our most important discovery. How low must the low dose be to be effective and safe? This one, picograms, femtograms per milliliter. This is what you find in these bottles. Why this concentration? 5 minutes of molecular biology. Why this concentration is so important? Because you have to focus on this structure on the surface of the cell. It is the transmembrane receptor. I reproduce this picture at the flip chart. Look, this is a cell. This is the transmembrane receptor. This is the extracellular matrix. This is a blood capillary. This is a lymphatic capillary. In other words, I made the microcosm of the body that is the macrocosm. Okay, why is so important the transmembrane receptors? This is a very important passage to understand these products. When I release through the blood capillary in the extracellular matrix a quantity of cytokine, hormones, neuropeptides or growth factors that is not the physiological one, picogram, femtogram, but lower, the molecules are so few that are not able to stimulate the transmembrane receptor. Remember that these molecules are called messenger molecules. They bring to the cell the message for the biological function of the cell. If you use, instead of few molecules, too much, like in Western pharmacology, plus, you induce a mechanism that in molecular biology we call down-regulation of transmembrane receptors. They close themselves. It is a defensive mechanism. You are stimulating me too much and I close the receptors. But if the cell closes the receptor, the cell doesn't work more. Side effects of high dosage of these substances. The only, this is amazing, the only concentration able to induce the opposite of the down regulation. That is, the up regulation is femtograms, picograms. I mean, using these substances in this concentration, you open the transmembrane receptors and you multiply the transmembrane receptors. I have this slide that show you very well. Okay, this is a neurotransmitter. If you have a lot of neurotransmitter, you don't express transmembrane receptors. Instead, in order to survive, if you don't have enough neurotransmitter, the only way to catch all the molecules of all the few molecules of neurotransmitter is to multiply the transmembrane receptors. This is what we do, providing our low-dose medication. We induce the multiplication of transmembrane receptors at the level of the cell membrane. Up regulation, down regulation. If at the university you have been working in molecular biology, you know very well these mechanisms. This is the law of I love you. I need a woman. No, not I need a woman. Not I need a woman in my life. I need a woman now. Please, you want to? Okay, the same. I know that is the dream of every woman.
You're Italian.
I'm Italian, and I am testosterone in physiological concentration. Okay, no, but this is a nice joke, but it will make you understand perfectly the molecular biology. Okay, crosstalk. Two cells have to communicate each other. Stay there. This is a cell. For instance, a cell of central nervous system. This is a cell of the endocrine system. Between the two cells, we have the environment. In our body, the environment is the extracellular matrix, the micro environment. The cells can speak each other using which kind of words? Hormones, for instance. And they can understand the hormones because, thanks God, they have the transmembrane receptors on the surface. So this cell, to communicate to this one, send a mail that is an hormone. The hormone has the trip in the extracellular matrix, and here we have the binding. Now, make an anthropomorphization of the cell. Okay, I am this cell, endocrine cell. Your name?
Anne-Marie.
Anne-Marie is a cell of the central nervous system. Here is the extracellular matrix. I want to communicate with Anne-Marie, and being an endocrine cell, I send an hormone. But in this moment, I am a man, and Mary is a woman. So, the right message is, Anne-Marie, I love you.
The right message.
It is the right message. I'm a man, you're a woman. But what we discover in our laboratories, that is important, not only the message, I love you, but the volume of my voice. Because if I tell Anne-Marie, look, the concentration is so low that the message is right, but I'm not able, to stimulate the transmembrane receptors that in this cell, Anne-Marie, is the ear. If I do the opposite, as a crazy person, I scream, I love you. Look what she does. She down-regulates her transmembrane receptors, the ears. If I want to have dinner with Anne-Marie tonight, I have to tell Anne-Marie I love you with the right voice, like Jeremy Irons. I love you. Okay, in our drugs, thank you very much. In our drugs, we reproduce exactly, in terms of concentration, the volume used by the cells to pick each other. That's really the reason why we are having this great success. Otherwise, you close. Otherwise, you don't stimulate. Is the law of I love you. And I explain in a romantic way. It is very efficient. Otherwise, I can try to explain in terms of dissociation constant. It's very complicated. But molecular biology says, yes, guys, you are on the right way. Not only the right message, but also the right volume that we reproduce in these medications. Now another interesting thing, because I want you to be convinced about the efficacy of these medications. So, after the lunch break, we will jump immediately into the clinical applications, even though some clinical applications already have been shown to you. 170,000 to 400,000 billion. What does it mean? Okay, I told you that to be effective without side effects, we use our medication in a concentration that is 10 femtomole per milliliter. In terms of molecules, how many molecules we have in 20 drops of our medication? I can tell you 170,000 moles. It is too little, too much? It's nothing. It's absolutely nothing. Just consider that in our body we have 40,000 billion cells. So we only have 170,000 molecules. You don't bind any receptor. Plus, growth factors, hormones, cytokines are proteins, glycoproteins. You administer these drugs by oral. How can it be possible that a protein pass the stomach barrier, not being digested? You understand? Instead, they work. It's very important how we prepare these low doses, according to a method that is called, and if you come to our laboratories to visit them, you will see this, sequential kinetic activation. It is a drug delivery system that uses the water to deliver the molecule of active principle. Bulletin of Experimental Biology and Medicine in 2012 for the first time spoke in terms of release activity. Scusate, this is in Italian. That is the capability of the basic substance to release in water their pharmacological activity. This is absolutely interesting because we use the water to amplify the activity of the very few molecules of active principle. It's a low dose. What happened? I try to explain in a very, very synthetic way. When you solve an active principle in water, for instance, this is interleukin 10, okay? You have the solvatation of the active principle by the molecules of water. In England, you call it, in English, in your countries, you call cluster this structure, okay? In cluster, the molecules of water are very tied to the molecule of active principle. And what is important, this is the most important information, all the substances interleukin-10, arnica montana, benzodiazepine, every substance release electromagnetical waves. And we know exactly which are the characteristics of every electromagnetical wave. The molecule of water, please pay attention now. Molecules of water are able to intake, to absorb the electromagnetical wave and to transfer to other molecular of water, But not all the type of water are able to become a drug delivery system. Exactly, an electromagnetical wave delivery system. This is the structure of the ordinary water, this one. All the dipoles are disaggregated. Yes? Electrical dipole, hydrogen, hydrogen, positive charge, negative charge, oxygen. Covalent binding, hydrogen, hydrogen bridge binding. In ordinary water, all the dipoles are disoriented. Because of this structure, the electric resistance is very high. I mean, this type of water is not a good electromagnetical conductor. Look at this structure of water. This is what happens also in the preparation of homeopathic remedies. In this structure of water, all the dipoles are in series. Since this structure, they have a very low electrical resistance. It means that this water is a very good electromagnetical transfer. How to make this ordinary water, such as biological water? In our laboratory, we standardized a method called sequential kinetic activation, that is to irradiate the ordinary water with precise frequency, UVA and UVB, that start orienting all the dipoles in series. And then, when we solve the active principle in this biological water, as we call it, we agitate vertically this way, so that we imprint the water with the electromagnetical information of the original active principle. So, even though we have only 170,000 molecules in 20 drops, and in our body we have 40,000 billion cells, what binds the transmembrane receptor is not the active principle, but the molecule of water that inside deliver the original electromagnetical wave of the active principle. And look that at the university we learned that the binding between an hormone, for instance, and its receptor is like key in the door. No? It's not this way. Now we know that the ligand establish weak bindings that are hydrogen bridge binding and covalent binding. Water is able to establish this type of bindings. So what stimulates the transmembrane receptor is not only the active principle, we have few molecules, but are the molecules of water. This is very interesting, and it explains also how this medication administered by oral can pass the stomach barrier. The water doesn't have any problem to pass the peptidases enzymes in the stomach. I wanted to tell you, this is a quantum physics, so it's very complicated. I try to explain in a very easy way. but it's important to also know this part of pharmacodynamics to understand how it's possible that femtomoles can be effective on peripheral cells. That's the reason why. And it is so true that we have a lot of evidence. This is a study with the University of Milan, effects of different doses of interleukin-1 beta on isolated human fibroblasts. It is a little complicated, but I try to make it very easy. Interleukin-1 is the trigger of inflammation. When you provide in culture interleukin-1 to fibroblasts, interleukin-1 binds its receptor. After the binding, inside of the fibroblast happen a lot of reaction, and especially we have the production of these proteins, the protein that is called NFKB. Is a nuclear factor that goes inside of the nucleus and stimulate the cell to produce pro-inflammatory mediators. In molecular biology, if you measure the expression of NFKB, you are measuring the effectiveness of interleukin-1. And these are the results. These are Western blotting. LPS is a positive control. I mean, the quantity of NFKB produced by the fibroblast when in contact with lipopolysaccharide. A is the negative control, placebo, water and alcohol. You can see that the cell expresses NFK beta, B, because of the alcohol. And now the most important part. B, quantity of NFKB when the fibroblast has been incubated with Western concentration of interleukin-1, nanomoles, a lot of NFKB. But after 24 hours, this cell went in apoptosis, died, dead, completely dead, the side effect. C is the quantity of NFKB produced by the fibroblast after binding with guna concentration. In terms of standard deviation, we can say C and B are the same. And you know what is D? D is the quantity of NFKB produced by the fibroblast after binding with guna concentration, femtomoles, but not SKA. You see? Nothing. So, the secret in the efficacy of these low doses is the preparation method we use in our laboratory that is called sequential kinetic activation. Otherwise, you don't have any effect for that. Okay? 100% of clinical safety, 100% of molecular efficacy. Okay, and now let's go to prepare for the clinical application, studying how to use this medication.
Can I ask you a quick question?
Oh, sure.
Just curiosity, how did you figure out that you had to do that to the water to make it work? Did it come to you in a dream?
No. The water, in this moment in the world, the water is the substance that the scientists are studying more. And we cooperate with the Institute of Quantum Physics of the University of Milan. They prepare all the devices to have this type of water. We don't know, we maybe know 1% of the possibilities of water, but the water can be the real drug delivery system. Actually, we thought of the water because we come from the tradition of homeopathy. And also in homeopathy, not in a so standardized, precise way, they prepare low doses not of biological molecules, but of natural molecules like arnica, with a similar procedure. But the water has a lot of possibilities.
You've actually seen the water molecule binding to the ligands. It's not a theory.
No. It's the release activity, and if you want to know more, you can. I will give you my email. If you want, I can send to you this reference about the release activity. That is exactly the way the molecules of water bind the transmembrane receptor, establishing weak bindings. Van der Waals forces and it was not covalent, excuse me. Van der Waals forces and hydrogen bridge binding.
Have you seen, sorry Alexander, have you seen the documental actual film about the great mystery of water?
No.
I recommend you can find it in YouTube. It's a great mystery of water. Let's try to explain what water is.
Yeah, but for instance, Japanese
the Japanese scientists say some good things, some good words to one writes in water, and he ignores the second one, and he says the bad things to the...
Absolutely, but for instance, how different type of music orient the deep pulse. For instance, if you irradiate ordinary water with Bach music or Mozart music, all the dipoles are coherent. If you put Van Halen or I don't know, Metallica, you see the molecules of water completely disaggregated.
And another question, you have not ordinary, the structure of water in your solutions. But you recommend, for example, to treat the osteoporosis, it's just the bottle method. So you dilute this structured water inside the ordinary water. And how they...
No,
really
they don't mix. The ordinary water, no, you
so
don't
they
need
don't
to.
mix?
No. When you, the medicine is stabilized. We have a test of stabilization, and for 5 years, otherwise we cannot put in the market, for 5 years they are stable.
So they do not communicate?
No, you use the ordinary water of the bottle just as a support.
Okay.
For instance, I don't have time to, since I am always on travel, I use directly under my tongue the medications.
So if we will, for example, to do some kind of experiment in that water, where the diluted the solution, we will find, like in molecular way, we will find the stabilized water with the
this is
just the ordinary.
This is just a support. It's just a support, but you don't need. You can put directly. It's important to recommend your patient that both directly under the tongue or through the water to keep into the mouth for 30 seconds, 1 minute before swallowing. Because in this case, in this way, you use the mucosal absorption. Okay, since you are giving few molecules, at least those ones are immediately absorbed. Okay, let's go to the immune system. And